Welcome to Biota Live. I'm Tom Bartley, and this is being recorded live on TalkShoe, May 14th, 2010. Biota Live is a continuation of the Biota podcast. For more information on the Biota podcast, check out biota.org/podcast. And we're returning to the Friday night recording times, or at least the Friday night Pacific recording time. So the next recording will be on May 28th at 8 p.m. Pacific. That's a Friday. And the topic will be artificial life on mobile platforms and robotic intelligent agents. And I thought the two things went together rather nicely, and they're both topics that I've been wanting to discuss on Biota Live for some time. Hello, Bruce.
Hello.
So we got some exciting news with regards to A-Life 12 this week. Would you like to share that with the Biota Live listening audience?
Yes, the conference program committee went through all the over 212 or so submissions and selected some, and happily I have to report that our EvoGrid paper was one of them.
Yes, it was a nail-biting conclusion. I think all involved thought that the competition was going to be pretty stiff, and when I first saw the email in my in-tray, I opened it with some reservation.
Yeah, I was expecting a marginal score, and that would have been sort of probably not quite making it, but there we have it. It'll be in the proceedings, and it'll be in the conference.
Very good, very good. And you're going to be representing the team there?
Yes, I'll be there, and actually if there are enough papers in the Origin of Life session, I'll be co-handling that session with one other person, and I'm also, they've put me on the artificial chemistry session, so I'll have some duties. And in addition, they invited me to present a tutorial, so I'll be pretty busy there in Odense, Denmark.
Gosh. And really, the EvoGrid is at a turning point. I think as I worked with you on the paper, we were looking at the results and anticipating that there would be a need for some new and exciting results in time for the A-Life 12 conference. Can you talk a little bit about, not necessarily the change of direction, but the kind of results that you actually need for A-Life 12?
Yeah, what we really need, and this is a discussion, of course, I'm having with Peter at the moment, is we need to show that, and Peter's building the bond formation code, that we can actually show the stochastic hill climbing algorithm working in a variety of modes. And for the audience, what that means is the whole idea of the EvoGrid as it's evolved to today is to distribute thousands or eventually millions of small simulations that look for and search for really interesting things in artificial chemistry, things that might be of interest to a bigger simulation of an origins of life scenario. So we'd look for the formation of key molecules or structures formed out of molecules like membranes and things in the small simulation space, and then use those same parameters that searched and found that to feed a bigger simulation space so that membranes might form there too.
And the idea is that there are components of the EvoGrid which are almost not necessarily continuously replaceable, but at least continuously upgradable as algorithms change and potentially the simulation space becomes richer. This is really implicit to the EvoGrid design, isn't it, Bruce?
Yes, and actually the idea that you could run a variety of artificial chemistries or a variety of molecular dynamic simulations at a variety of levels is sort of a really integral part of the idea. Some of the reviewers did point out in their reviews that this is a very hard problem. It's a hard problem to take, say, GROMACS or LAMPS or an artificial chemistry and package it up to run in a uniform framework. That's a hard technical challenge, but it's also hard to run one simulation at a low level, say the molecular level, and another one at a higher, what's known as the mesoscale or granular level at the same time, and go between those levels. That is a very, very hard information science problem.
Certainly. And I believe we have Jeffrey Ventrella on the call. Hello, Jeffrey.
Hello.
Good to talk to you. I was looking through the Biota Live archives, and it's been many months since you were last on Biota Live. I know you've been to ACAL and had various other adventures since. Would you like to kind of give some follow-up discussion to what you've been doing since you were last on Biota Live?
Oh, gosh. Do you remember what month that was?
It could have even been like July last year. I mean, it really has been quite a long time.
Yeah. Is that Bruce on there?
Yes, it is.
Hi, Bruce. How you doing?
Very fine, thank you.
Good. Yeah, well, as you know, I've been up in Vancouver, Tom, back and forth, doing some research and teaching, and I'm back here in the Bay Area now, and just got lots of things cooking on the slow burner.
So in terms of artificial life on spheres, the stuff that you did for ACAL, I know you've been in contact with Gerald de Jong since you got back. Can you talk a little bit about artificial life on spheres, what you've kind of discovered and learned, and where you are in your current artificial life on spheres investigation?
Well, I guess there are a couple of threads. Gerald and I did have some great conversations. He's been thinking about spheres a lot, and he's also thinking about them in terms of tensegrity structures, which is very closely related to polyhedral and geodesic structures, and the various anomalies and properties of those. One thing that did come out of it is that I wrote a paper related to cellular automata on spheres, and that's going to be coming out in a book that's edited by Adamatsky about game of life cellular automata. So I guess he's collected a bunch of authors to write papers about that.
It's 40 years, isn't it?
What's that?
It's 40 years since Conway's Game of Life. It was like 1970.
Maybe the timing is critical here. Yeah. But basically what I did was I implemented I was trying to figure out a way to implement a particular computational machine on a sphere, and I came up with something that implements the XOR gate, because I had seen some of the work of these guys that have been coming up with using glider guns and things to make different computational components. And so I came up with an idea for something that runs on, that's unique to spheres. And that's actually available on my website. I forgot where that is. But anyway, that'll be coming out in a book soon.
Terrific. And can you, I'm not giving away too much, but can you kind of fill in some of the gaps for folks listening in?
Gaps as far as...
As far as XOR gates, spheres, the whole working, I mean, what is it in a kind of potted description for folks listening in?
Yeah, well, I think one of the motivations for using the game of life or any cellular automaton to simulate, which is a term that has been used, the logic gates, and I put quotes around simulate, is so that to explore the idea that logical circuits or logic can emerge from space-time patterns as opposed to from traditional computational mathematics that we use in computers. And in that sense, it's a kind of an artificial life related topic.
So you're talking about iterative patterns here.
Iterative patterns that require time and some kind of space to unfold, as is the case in reality, which is not the case with numbers and mathematics. Or that could be debated, I suppose. But who is it that calls it artificial? That calls it a chemistry, computational chemistry. One of the A-Life guys uses that term. At any rate, so my question was, a universal Turing machine requires infinite space to allow for infinite size tape to compute anything. But that's an imaginary situation, and in the real world, there are objects and machines that perform computation, and so creating a spherical computation machine, I think, is it doesn't allow for a universal Turing machine, but it may model real life things, if that makes any sense.
So the surface area of the sphere, rather than the ability to actually communicate through the sphere, I could see an argument if the information could traverse through the sphere, but over the surface of the sphere, what's the property that you're getting over the surface of the sphere specifically, or can it actually communicate through the sphere as well?
Yeah, no, that's a good question. I think actually what I just said about simulating objects, that really isn't the goal. The goal is more, actually the motivation was coming from the fact that the torus is the object that comes out of wrapping the opposite edges of the rectangular domain in a typical CA. That is a 2D CA, resulting in a torus. And the advantage of a torus, of course, as we may have talked about before, is parallel lines are conserved. And gliders, for instance, moving across the surface will encounter the same basic texture of time and space throughout their journeys, whereas on a sphere you have positive curvature. And so the trajectories of objects, such as gliders that are trying to move in a straight line, will encounter different properties. For instance, a glider moving on a sphere that's moving in a straight line, that is, in terms of a sphere, is actually moving in a great circle. So two gliders will actually collide, or their paths will cross, whether or not they collide. And that's a different kind of path-crossing scenario.
But certainly in a torus, I mean, the toroidal shape versus, for example, a cylinder, where basically you have like one-to-one mapping with regards to at least one of the planes, the toroidal has a flip kind of curvature in it as well. So I understand the notion of parallel lines moving across, and I don't think this is a conversation that's come up on Biota Live, but the nature of the flip that you get in the toroidal element, how is that described in terms of maintaining structure?
The flip? I'm sorry, did you say flip?
Yes. Well, I mean, there's a turn in it which gets it into the toroid versus like a cylinder where there is no turn and there's a direct, I mean, there's X correlation all the way around. So I'm just trying to understand the...
Well, topologically, I mean, a cylinder is topologically equivalent to a sphere, whereas a torus is a different class topologically. So you could map the same grid from a cylinder to a sphere, and also from a sphere to a cube, any polyhedron, any closed object. So I think it's really, the question is not so much whether it's a cylinder or a sphere or a cube. It's really what's the grid, what's the nature of the grid, and that's where the grid, the nature of the grid, is what changes the way gliders move, and thus computation. So, yeah, I don't know if that's answering your question, but
certainly. Well, I have my fingers on your short book, Prime Numbers Are the Holes Behind Composite Patterns. It's not really an artificial life book, but it is on the kind of cusp of this mathematical modeling and the very nature of mathematical space. Would you like to give an introduction to the book?
Sure. Well, like probably many people who are interested in patterns and numbers, I drew a little pattern that many people have drawn as well, and discovered patterns, which is basically if you draw the numbers along the number line from left to right, and beneath each number, you draw in a column the divisors of that number. Obviously, you'll have a lot more numbers below the number 12 than 11 or 13, which would be an example of twin primes. And so these patterns emerge. Now, the question is, what kind of patterns emerge in the area of 2 billion or 12 factorial, these very large numbers? And the patterns are very complex indeed. And not only that, but there are very interesting structures in there. And these structures can be thought of as the kind of the profile of composite numbers, which could be thought of as the figure against the ground of prime numbers. So when people are looking for prime number patterns, which people have been doing for a long time now, you can look at the patterns of composite numbers as a way to maybe get a better understanding of the prime patterns. So it's not really a book about primes per se. It's a book about looking at the trees in the forest to better understand the spaces between the trees, which is one way to look at it, and just a celebration of these very cool patterns.
Certainly. Now, as I read through it, there were a number of points where I both took notes and also thought about kind of counterexamples and other things. I think it was a fascinating book for me. I mean, in terms of your background with mathematics, how much mathematics have you done? Have you done number theory? Have you done these kind of things? Or are you strictly taking it from a kind of artistic experimental perspective?
Yeah, well, I think I mentioned at the end of the book that I don't have a mathematical education, and the interest in math is purely an outcome of the visual exploration. And so I actually advocate that this is a way that young children can learn math instead of learning the equations first and then later perhaps accidentally discovering why those equations are so cool and who discovered them and how and why. They can sort of delve into the visual, spatial, or in some cases musical realms where math can really be appreciated.
Yes, it's fascinating. I mean, from my own experience as a young child just using Quick Basic, I was able to create trigonometry from the areas of circles and these kind of things. And you're wondering what's not being about that specifically gives a kind of playful narrative to how to explore the number space. And I think there's an element in that in a lot of artificial life projects. I think a lot of artificial life projects have some component, whether it be boundary problems, whether it be understanding how genetic algorithms are ultimately finding, the best possible fitness. I mean, these kind of things all lead back in some way to the topics that you discuss in prime numbers, the holes behind composite patterns. And I think certainly as I read through, a lot of my paper notes relate to calculus and trigonometry and solutions to the number space, which I think, I don't know, I mean, my own exploration through these topics came from what you're describing initially in terms of playful experimentation, particularly with access to computers occasionally and scratch papers certainly considerably more, but then actually formally studying some of the background to this at university. What I found fascinating was how far you got in terms of kind of getting to the end and realizing that your training had not formally been in mathematics, but more in kind of artistic play as a means of exploration. I think it's a very powerful book in that light, although there were certain points where I don't know, I find this when I read and certainly when I listen to lectures and other things, I'm probably good that I'm not there in person because I would be calling out counterexamples and things like that. So for me, I found it very good. I found it very motivating, and I think there are certainly in Noble Ape there is a section that relates to factorials and primes and composites as well in terms of various effects. So it certainly resonated heavily with me. And it also reminded me that I probably should send you a copy of the original manuals. At least thumb through that section too. So a topic that I wanted to bring you on to discuss is reinventing all old projects, but also finding this boundary of learning. And this is something certainly that Bruce and I and Peter Newman and other folks in the EvoGrid team are coming to. You get a sense when you're working on a project, when you kind of reach the boundaries of your own play space. And I think what fascinated me reading through the Prime Numbers book was my sense that it would really go on to inspire people to actually look at the boundaries of their own areas of knowledge. In terms of your own, I mean, when you've developed artificial life applications, when have you found that kind of boundary where you've had to go off and actually, read biology texts or these kind of things? Can you describe that translation where you hit a boundary and realize that you probably need to actually explore the science?
Well, I guess it depends on the most recent example and whether or not it's considered central to artificial life is this spherical CA stuff that I was doing. The reviewers who read it came back with some comments, and one of those was what I just mentioned, the idea of a universal Turing machine. So I had to go back and do a little learning about computational computer science and all of that kind of stuff, and that was kind of fun to learn that.
Certainly, within cellular automata, and I found this through, as you say, submitting papers and getting feedback. There are many different, quite amazing kind of subclasses, particularly going back into the 50s and 60s. There was a lot of stuff done on cellular automata before Langton ever coined the term artificial life, and obviously Conway 1970. And I think what you've given is another good example that actually part of the academic process is actually kind of fishing almost for this kind of information. In terms of aside from submitting papers and these kind of things, I mean, when you were developing gene pool, for example, did you find that there were points with regards to the movement or things of this nature where you had to go back and look at primary research, or was that all kind of a priori generation?
Well, yeah, I think that's a good question. I would say mostly it's when it comes time to write a paper and to present at a conference. That's when those times I had to check and make sure that I had my facts right, and so on. And there was also I remember when I decided I wanted to try to have some kind of a closed energy system, and I don't want to claim that I've done a great job of that, but at least I attempted to do that. Having to learn a little bit about that. I think there are different approaches to A-Life. One approach, and this is perhaps just different styles and methods that people have of making things in general. Some people might have more of a tendency to get their head around the science before they start generating a simulation or building a model. And other people might be more free-form about it and just start building something and watch what emerges, and then kind of look into the background and see if what has just emerged is somewhere in the literature or has been done before. I would probably be in the second camp, build it and see what happens, and then create something novel, and then learn from that. And then, of course, build it again, which doesn't always happen.
Certainly. The iterative wheel, head above the parapet, has anyone else built this wheel before, head back down, redesign, kind of method. Bruce, as you listen into this, I mean, the EvoGrid has obviously presented a number of points where you've had to return to the literature and get a sense of what else is going on. This obviously resonates with your experience with the EvoGrid. Can you give some examples of this with the EvoGrid?
Yeah, I mean, in a sense, we started out the project being quite naive and saying to ourselves, well, we'll just take a good artificial chemistry, or actually a molecular dynamics engine that is qualified and built by chemists and runs on one machine pretty fast and even on a grid, and we'll modify that and put a feedback loop and try to run a search algorithm for cool stuff. And then we found out that the actual interactions between these virtual molecules and atoms were a lot more sophisticated than we thought, and that they hadn't fully implemented a quantum mechanical model. So we then had to implement a naive model, which we're still in the process of doing. And then we find out that there's probably as many approaches to simulating the molecular domain as there are people working on approaches to simulating the molecular domain. And then there's a whole range of people who are saying, you can't do this stuff at the molecular domain. You can't generate anything interesting biologically doing it because it'll take you years and years of computations. You must do it at a higher level, at a coarse graining level. And then we find out about people who are spending $100 million to build hardware, and they pronounced that they could do, I think it was a microsecond a month of real-time chemical simulation for a reference volume. It was like a microsecond. Wow, a microsecond. And when you're thinking of simulating origins of life, and certainly the Earth's oceans within a microsecond, when they were the primordial soups days, they didn't do a whole lot in a microsecond, and that was an entire planetary ocean. So, your mind just kind of goes out to infinity trying to wrap itself around this problem, and trying to then shoehorn it into von Neumann computers, and then you realize it's, you could conclude that this is a fool's errand. This is so large, and so then you tighten the screws and you tighten your grip, and you say, well, can we make a contribution? Can we still do something? And that's the honing down process. So in Jeffrey's classification, we're definitely in the first category of trying to get a handle on the science and who's done what and how big the problem is, and then finding a fit where we can write a paper that a conference will see as new work or significant work and accept. So we went on that journey, and we're only really in the last few months running simulations. So all of that happened before we were running much of a simulation, and we still have to do a lot of work on running actual simulations.
Yes, I really like this idea from Jeffrey of the notion that there are times where you need to play and build, and then there are times that you need to look up. But from what you're describing as well, there's also this process that there's a kind of noise impossibility aspect that when you look up. And I think this is interesting in terms of the notion of being able to filter that in some productive sense. I mean, ultimately, certainly reading through Jeffrey's Prime Numbers book, my sense was that this was more a kind of play exploration, but from this, there are, at least a dozen points where people could go away and study in particular areas. In terms of what you're describing with the EvoGrid, in terms of the people that say that this is impossible, or people that are doing existing research, how have you been able to navigate personally through all of that?
Well, it's been a challenge because there are people who I would say are coming from the naive artificial life side that are building very, very simple little worlds. And I got the chance, being part of this the conference, to review quite a few papers, that were submitted. And truthfully, a lot of what they would call artificial chemistries and cellular automata and things like this, I mean, you look at them and there's impressive results. I mean, you've seen these little GAs with strings and properties of the strings and what seem like phenotypes and genotypes working together. But then you ask yourself the question of what use is all that? You can make 100,000 or 1,000,000 or 1,000,000,000 different GA universes that are ultra simple, have very trivial physics, and they'll all generate neat and cool properties, but what value is it? And then the chemists are on the other side saying, yeah, well, we just don't pay any attention to any of that stuff. We're molecular biologists. it's interesting to us, but it has no bearing on our work. But then you switch over, you say, okay, we'll do we'll do molecular dynamics, and we'll try to do the real stuff, and then you find out it is so hard. Mm-hmm. So where do you land? If you want to see evolution in your system, it argues for making a pretty darn simple system. But then the properties that come out of the system are a toy model, and people throw up their hands and say, well, how nice of you to do this, but it doesn't inform my work in biology and in origins of life. And so it again, you're kind of in this loop all the time. So there you have it.
But it's a productive loop, and I think I'd like to explore really this idea of reinvention, this idea of constantly coming back and refining, and certainly with Jeffrey's experience, the stuff that's gone on through the history of kind of gene pool-like projects seems to see you revisiting this problem every 3 to 6 years, getting slightly more insight with regards to user interface and expression. Can you talk about this productive reinvention process that seems to be so central to what Bruce is describing, and also your own experience as an artificial life, Jeffrey?
Well, I definitely agree. It's good to come back and review these things, particularly as one ages from age 20 to 30 to 40 to 50. Our brains are losing details and gaining wisdom. So each time we come back, we come back with new wisdom from 10 years of life. That is to simplify it into 10-year increments. And I actually think that, as far as what Bruce is talking about, Bruce, I mean, you could come up with a new model, right? Instead of, you may not be able to model something on a quantum level, but perhaps you'll come up with a whole new way of thinking about a whole new way of representing these tiny little interactions over time, and doing it in a cheap and efficient way that comes up with results that can be looked at and insights gained from. So I think it's definitely worth continually coming back to it and staying naive. Buckminster Fuller said, "Dare to be naive." He tried to stay naive all his life, and he was a great inventor the whole time. So I think continually coming back and not giving up because people are saying that's impossible, I think that's key.
I mean, certainly from my own experience, what I'm finding currently, and because Bruce and I are working on similar writing projects, the nature of constantly producing text, almost this, in Bruce's case, actual academia, in my case, pseudo-academia, does give you this kind of, turbulent, almost tornado-like perspective with regards to the various kind of intellectual communities that one is a part of. But I agree with you entirely, Jeffrey. In fact, my own thinking is looking past this current whirlpool of writing with the sense that there are things that I want to be doing in Noble Ape, and also in kind of broader sense of the Biota community, which will reaffirm the reasons that I develop artificial life. And I think this is a familiar theme. I mean, certainly even Tom Ray, when he talks about leaving the artificial life community, still seems to be advocating projects which seem to be very artificial life centric, almost like you can't escape the themes, basically. So in terms of your own experience, Jeffrey, and you described it perfectly, I know that the decade intervals are probably, could be plus or minus 2 to 4 years. But in your own experience, can you kind of characterize your progression in kind of decade increments?
In terms of any particular project?
I don't know. I mean, I think obviously your artificial life projects are most applicable to the discussion, but I mean, if you have another project which is even more striking in this regard. One
thing, if I may continue on this sort of aging sort of theme, because I'm approaching 50, right? And so I'm thinking about how does a 50-year-old or 60-year-old mind continue building things? Like, will I ever build another gene pool? I may not. In fact, I find myself making smaller and smaller things that take less and less time. Quantity over quality. I don't know if it's over quality, but making a lot of little things. I don't know if that's the nature of computing, just the way time is so compressed in the world these days, or maybe it's because my attention span or my ability to delve deep into a large project and keep my head around it is decreased with age. But I wonder how. You and I have talked about gene pool and about how it's probably time for it to be handed off to the world or handed off to someone out there, because it's really not something I can maintain, and it seems like the longer time passes, the less I feel like I can come back to it. So, it's just something to wonder about. But I am finding myself making lots of little things. I'm not sure why.
Certainly what you describe it with regards to 50. I certainly felt it with regards to 30, so I don't know if there's a logical progression through, but certainly the movement between doing the amazing, broad, exciting things oneself and then kind of kept passing the torch on to other folk who were feeling a similar energy at a similar time is, I think, a continuous theme within artificial life, and certainly the reason that I embraced open source so many years ago was for this very reason, that I knew that there would be people in their teens and 20s that would have access to it, and I guess this is the motivation. Bruce, your movement towards the Evo Grid is also part of this kind of progressive life history. What's your own sense in terms of Jeffrey's narrative?
Oh, it's definitely true. For example, I was hot coding stuff on this way back in the 80s, and then a little bit in the 90s when I was in my 40s, and actually my 30s. But then I decided that, if you sit and code a large system, years can go by, and if the system doesn't go anywhere, you're kind of out of options and out of energy. So I decided instead to become to quote our current president, a community organizer, and found things like Biota and do avatars and get good at writing grants, get good at networking with groups of people and form organizations and hold conferences and things, because I felt that in the long run, that will give you more options. So when it came down to returning to this vision of the Evo Grid, when I finally got back to it, I was 45, and I realized I can't write a line of code. And Peter Newman, who'd worked for me at that time for about 8 years, building all of our NASA projects with digital spaces, he wouldn't let me write a code. I mean, he couldn't stop me, but he basically said, you shouldn't be doing this. And Peter is doing it. He's doing the code writing work that I really can't and shouldn't do. And so my natural role is out there, writing the conference papers, trying to get funding, networking, trying to figure out who's doing what in the field so that our work is relevant and makes a contribution. And I like Jeffrey, I'm approaching 50 in a couple of years. And I see that I think I'm very comfortable with the role where I'm fitting, and I can't write code anymore, and I can't even write little things anymore. But I can write a good proposal, and I can do a good presentation. So I think that's just natural. And once we find more support and more funds for Peter, I'm sure that he will in turn hire younger people, and he will be the chief architect, and we'll just continue the project. It's just a natural way of doing things.
And I think certainly my own discussions with regards to the Evo Grid tend to return. I feel like the oldest curmudgeon on the Evo Grid team a lot of the time, actually, primarily because I think Peter can't continue this process in complete isolation, particularly with regards to the plentiful supply of chemists and physicists, and even young emerging chemists and physicists very close by him. And certainly my own experience studying physics now, I guess 10 years ago, maybe even close to 15, the stuff that he's encountering is still relatively fresh in my mind with regards to quantum mechanics and particle interactions and these kind of things. So I think there's the combination of factors, and what Jeffrey was really discussing, which you seem to be echoing, Bruce, is this notion that part of it now is almost in the field of mentoring and almost, as you do with the Summoning the Evo Grid tour, kind of describing a partial vision of the future that needs to be added to by the people consuming the various lectures and audio. And I think this is kind of an ongoing theme. Jeffrey, returning to this idea of reinvention and rebuilding, you've talked about moving the gene pool source, open source. I've had some correspondence recently with a fellow who is trying to get me to instigate Steve Grand, who passed me a substantial amount of source and then decided that he didn't want to actually release it open source quite yet. In terms of the kind of progression, when you pass it on to the internet, some community, potentially some interested 19, 20-year-olds, do you get a sense of the kind of support and documentation and narrative that needs to follow, or do you really feel strongly that through things like Maciej Komańczycki's, Artificial Life Applications and Software, the kind of primary gene pool paper, that you've given enough information out with regards to this, or do you see that there's still some underlying narrative which is yet to be told with regards to this development?
Well, my goal is to write to make a book that would be sort of the gene pool book, and I would put that out there at the same time, or maybe a little before, as you suggested, or maybe a little bit after. Actually, yeah, you suggested a little after. At any rate, that would kind of go along with it. And kind of like Bruce, I'm probably better at writing a book about it now than making another code version. One issue that I found, and actually, Tom, thanks for helping me learn a bit about open source when you helped me take one project and put it on SourceForge, I believe it was. One thing I found out was that I really need to be a systems administrator or have some systems administration chops in order to put it there and kind of guide it. Now, I may be wrong. It may be that the thing that's missing is marketing it and promoting it so that people can come, and then what little sysadmin I need, I could learn. But I don't have the sysadmin chops, and so I'm not sure what the best way for me to pass the torch, as it were. I don't know if you have any insights about that.
So it's a multi-part problem, and it's also largely luck-based. In my own experience, it's come through probably half a dozen ways. A few of them are just brute force issues, which I guess are characterized by what you're describing as sysadmin. You need to maintain a project. For example, the project that you did release open source, the idea that people could put in their own music and there would be some development through that, almost like my concern, I guess, with Steve Grand's project, Symbiosis, is it really is just a complete project that he got to the point where it would probably make a commercial game, or at least be the beta of a commercial game, and that's how it exists. Uh-huh. The way that I've developed Noble Ape, even implicitly, even as something which I've just had to maintain for the various versions of the latest Windows or Apple operating systems, have meant that there's always some development going on. Yeah. Even if there isn't a direct release even every year, I'm doing source code changes in the order of at least a few a month. I mean, there's constant source code progression. I'm constantly tickling the source code in that regard. So maybe that's what you're describing with regards to sysadmin chops, things like mailing lists, wikis, these kind of things. The real luck that I have had is through a couple of occasional articles which have been picked up that have obviously gelled with a group of people. So I'm thinking perhaps of the Rushkov article in the late 90s, and that really, I've been developing Noble Ape for 4 or 5 years in relative isolation prior to that article, and certainly the basis of that article got me back to the US and in the Bay Area and doing all that kind of stuff. But also in later times, the kind of nature that not necessarily that we have predictive insight with artificial life, but we certainly can talk a lot more about emergent properties in the real world, flaws in existing science, these kind of things. So I'm thinking the H+ article recently, my time on Bruce and my mutual friend, whose name escapes me, who does the Sea Realm podcast. These kind of things have always kind of had ins which have brought in new community, but the main thing is just time. Open source is something which isn't measured in days, weeks, but really is measured in years, quite literally. And when I wrote for IEEE Computer Graphics and Applications in 2004, that was the takeaway that I gave, was that when you develop open source, you're not developing it for any immediate notion. Really, the ultimate kind of scratch-itch cliche isn't really true either. But after you've been doing it for a few years, I mean, the Apple example is the other example. I was extraordinarily lucky with regards to the two Apple engineers that picked up the source in 2003. So, but it's one of these kind of, well, if I hadn't been constantly doing updates and had a narrative blog at the time and all these kind of things, so it's not one particular factor. It's a series of these things that come together. And I think the strength that I've always found with your work, Jeffrey, is just how inspirational it has been. And this has also been a great frustration of mine, because I see aspects of your work, particularly in parts of contemporary game development, completely without reference and without sense. But I know the likes of Genova Chen have studied your work when they released things like Flow. In fact, Bruce and I, Bruce's acquaintance primarily at USC studied with Genova Chen and showed him your work. So I know that modern games that come out that have elements of gene pool in it, and also other aspects of your work, because I know your work, I can find the stuff that's out there. I think what I've tried to do, wherever possible, is re-educate at least those around me, and occasionally games journalists, that this is not just inspired by artificial life, but fundamentally is artificial life, if not fundamentally the children of artificial life. So I think you have probably an untapped fan base that doesn't currently equate your work with these things, but as soon as they become acquainted with your work, will immediately recognize it. The problem with regards to what you released initially open source is it wasn't gene pool.
Yeah, well, actually, Tommy, I think you made a good point. You were talking about your whole experience of making Noble Ape, and, like you said, you were tickling it several times a month. I think you had a very system and open approach to it the whole time. So it sounds like you were building it really with a community in mind of people taking part. And perhaps myself and Steve Grand both may have been working on a product kind of as a product. Maybe that's the key word, as a thing that is used, and it's not so much as an open, growing, evolving body of code. I'm almost thinking that perhaps if I were to, maybe the right thing to do is, instead of opening gene pool as it is, would be to perhaps open a collaboration with you and others, and we actually build something new from scratch based on it, and let it evolve in the environment, from the start. Because that's a whole different animal, and that's the kind of animal perhaps that needs to be there from the start to really become an open source powerhouse.
There's an interesting paradox which I think always needs to be stated explicitly, and that's this notion that when you do things in the open, you own them for longer than when you do things closed. And it's the real reason that I got into open source development primarily was because I had this kind of sickly sense that if this was in any way affiliated with, any of the individuals or schemes or experiences that I had through my life from a relatively early age, that these things were going to be discarded. The only way that this idea was going to maybe even post-date me, as I put audio on the Internet Archive for, generations to come. My sense is that the methodology that I embraced, and I've had this discussion with Steve Grand on a few occasions. In fact, when I first interviewed him, it was the section of the audio wasn't necessarily heated, but I think we had diametrically opposed views with regards to open source at that time, although progressively I convinced him otherwise. But really, my sense with regards to Noble Ape was that it had to be open source in order to survive.
Yeah.
And I think certainly I agree with you. There is potential for you to create something new, and really this is what I wanted to talk with you about this evening, is this notion. I mean, I constantly have new ideas in terms of things that I'd like to develop. I think the notion, and Bruce even touched on this with regards to the kind of pre-Cambrian aquatic environment. I think a three-dimensional, deep and rich water simulation is something that has always interested me, and obviously you're the thinker in the space with regards to these kind of things. So I could certainly see some collaboration in the future in terms of making maybe some three-dimensional version of gene pool, and I think here we would borrow Roy Plotnick as well, because I think in terms of the science, Roy is the man to talk to, and could probably give us a great degree of insight. I think I kind of floated this idea of a potential collaboration leading to something that was open source maybe 2 or 3 years ago. So I think this is good thinking to return to and actually do at this stage.
Yeah.
So Bruce, as you listen, and I mean, you've been using open source for at least a decade. Do you have anything to add to this narrative?
Yeah, basically, it's that for us, our experience in building an open source 3D framework with physics for NASA. I mean, NASA funded it. These big frameworks, like if you create something that, and Peter can talk to this, if you really want the expert on this, bring Peter on the program. But you build these things and you architect them well with good APIs and scripts like Python, and you document them, you put tutorials up and whatnot, but there's no guarantee that you're going to find an audience for it, somebody who's willing to download a big development framework and do new things in it, even in a popular area like 3D. So we've had sort of a little bit of people poking around in the platform, but it's such a time commitment to adopt these platforms. It's rare to find that, and you almost have to go out and then do marketing to try to get somebody adopting your platform.
Certainly what I'm finding, and this is going to be the topic for the next Biota Live, but within the mobile space, be it Android, be it iPhone, be it iPad, in terms of this kind of rapid development and also really strong sense of what projects actually survive, this new medium, and I mean, I lived in the Bay Area, 10 years ago when people were talking about this stuff for probably the third iteration. So let's just say what is currently at least being sold to millions of people and being carried around gives those of us that have had those experiences a new testing ground in terms of potential APIs and SDKs. I certainly think that looking at the iPad in terms of a new user interface, have you played with the iPad at all, Jeffrey?
I've seen it, watched it demoed, touched it a couple of times, but that's about it.
I mean, I get the sense that a gene pool, like particularly a 3D movement through fluids kind of environment on the iPad in terms of the interface, the touch, the drag, the twist, I mean, that is a new interface which really lends itself to a new class of artificial life simulations, particularly exploratory artificial life simulations. And I think the experiences that we've kind of collectively had could lend itself to something that was very organically rich. I mean, certainly your background, and not just MIT, but the kind of visual aesthetic interface aspects of a lot of your work. And I also, my personal feeling is that the iPad is actually analogous in many ways to the Palm Pilot in terms of the ease of development. Once you develop something on the Mac, developing something on the iPad is relatively trivial. And I think my own reflection is my experiences with the Palm Pilot was the same. So I think what we're seeing now is a new class of devices that almost lend themselves to the kind of simulations that maybe we're discussing, and also potentially creating the kind of building blocks which will be sticky to, a next generation kind of community that Bruce is talking about.
And not only that, but these have GPS and accelerometers and all of these things, so they're kind of embedded in real space in real time. So
certainly.
So, you can have an alternate reality artificial life program where if you walk over to Fifth and Main, you might have a more fertile environment where the creatures are living and thriving, and you go to a different part of the city where your friends are hanging out and they've got their creatures evolving. So, it could really kind of move into the physical world by being a mobile device in that sense.
Certainly. And I think there is a space and time element. I mean, what Bruce describes in terms of creating these kind of systems, and I've offline been quite an evangelist for the digital space environment in terms of, folks that have a background interest in space and also have a background interest in virtual worlds and computer graphics. I mean, this is kind of an apex of these areas. And I think the nature of developing open source means, yes, within any short time increment, there may only be a small group of people that are interested, but over a long period of time, and I find this particularly in terms of the core developers, be they at Apple or be they, folks at Intel or other developers that have stumbled upon the site who have spent, maybe a couple of years doing things associated with Noble Ape and then moved on in their careers or moved on in their locations. This kind of narrative is just the nature of open source. So I don't necessarily think it's a bad thing. I just think that it's kind of part of this organic progression. And certainly, I mean, Bruce, you've described this with regards to developers that have worked on your code from time to time as well.
Yeah, and truthfully, and this goes back to the aging question, I mean, you get tired out on code. I mean, not only you get worn out writing it, unless you're truly hardcore, but you kind of get worn out starting and running projects and seeing them to completion and debugging them and dealing with versions. I think it's almost like athletics. There's a certain age in which you can do this kind of thing, and then there's an age where it kind of wears you out. It's kind of beyond it. And I think Jeffrey and I maybe are suggesting that moving into the 50s and then onwards, we're, you just can't do this for 50 years.
Yeah, unless you continue to drink more and more coffee all the time, in which case you've got other problems, Yeah,
I stopped drinking coffee, and it's like stopping drinking alcohol. Your quality of life kind of continues going in the same direction. So I don't know. Eventually, I'll just be on water and I guess celery sticks or something like that. On this topic, I mean, I'm going to be in the Bay Area for just 2 days. 4 total, but 2 days productively. And I'm doing a talk at Intel on July 13th, which will then move over and have other discussions. So I'm pretty well booked on July 13th, but July 14th, until the talk at SRI, I'm just going to be wandering around the Bay Area like some kind of nomad. So, I mean, Jeffrey, if you're about, then I'd like to get together with you and have a good chat and maybe kind of draw out this idea of some deep oceanographic environment where the Cambrian explosion may occur once again, because I think that's probably a shared vision and could become quite a meaningful open source project.
Definitely. Are you there?
Yes.
Okay, I got a beep here for some reason. I'm looking forward to that very much so.
And Bruce, in terms of the next few months and your talking schedule, what's it looking like?
Well, I'm off to England in July, and I'll be doing a number of talks there, and possibly going back to the BBC for more programs on the work. And then August it's Odense, Denmark, and actually I'm keynoting a conference on A-Life and artificial intelligence in games in Copenhagen, and then I'm taking the train down to Odense to be part of the A-Life conference. So that's my little schedule.
Cool.
Yeah, the BBC's always been a good friend to artificial life. Certainly, when I was in the UK, and also with Steve Grand, there have been some interesting speakers on the BBC talking about artificial life related topics, and I'm glad you're carrying on this legacy, Bruce.
Mm-hmm.
And Jeffrey,
we love the Beeb.
And Jeffrey, in terms of the next few months for you, are you doing any talks? Are you doing anything that's artificial life related?
Well, a couple of things. I'm going up to Banff, Canada in June. I'm looking at them right now, a couple of fractal images that I made with the help of a genetic algorithm, and I'll be sending those up. And it's a conference called Smart Graphics, and it has a lot of AI-related talks as well as an art show. And so I'll just be part of the art show. And another thing that I think, Bruce, you might be involved in, we're hoping, is Scott Draves and I are on the committee to help organize an evolutionary art show at the Gecko conference in Portland.
Yeah, in fact, I just got the notice today about when the reviews will happen sometime in June. So
awesome.
Thank you. That's wonderful.
Yeah, that's great. So Bruce, you'll be one of the reviewers of the works being submitted.
I'm looking forward to it.
I recall last year Dimitri Terrazopoulos from UCLA was the keynote at Gecko. So I guess the legacy of artificial life in Gecko has been relatively strong, and it seems like it's continuing, Jeffrey.
Yeah, I actually didn't. I wasn't pursuing that conference, but I did get approached to be a part of the art show, and so that'll be fun. I'm not sure if I'll be able to go to it. I'm going to try to go to it. Yeah, it's. Has there been a strong artificial life component to it, or has it been more evolutionary computing?
Well, even prior to Dimitri's talk, there was one, I think, even at the Gecko prior that I received email about, and I can't recall who was at that one, but certainly Dimitri's talk, I got multiple emails from different people describing the talk and saying it was wonderful, followed by an email from Dimitri himself saying that he was approached by a lot of old friends and folks. So my sense is that the Gecko conference does bring together people who are at least artificial life sympathetic.
Yeah. Well, I'll try to go to it.
Sounds like a wonderful conference. Well, Bruce and Jeffrey, it's been a pleasure as always to talk to you both, and I know you're both going to be returning guests to Biota Live. My anticipation is to record either in video or audio form both my talks in the Bay Area. My understanding is that even though Bruce won't be at the talks, that Al Lundell may be at the SRI talk. Is that your understanding, Bruce?
You'll have to check with Al, but he's always up for those.
Terrific. And the topic on May 28th, it'll be a Friday, 8 p.m. Pacific, is artificial life on mobile platforms and robotic intelligent agents. And my hope is to have on a few prior Biota Live guests, potentially even Steve Grant, to talk on these topics, because in my own experience, certainly the mobile platforms are becoming increasingly interesting. Well, thank you both once again for a wonderful conversation, and thanks to folks for listening in. Good night.
Thanks.
Good night.